So once you've done all this, I think one of the traps you can face is you don't ask yourself the hard questions. So now the problem is, if you're a technical founder in particular, you have a technology you've been working on for 5 years, you really like it, you think it's really great, and you really want to push this technology. And I think you have to make sure you don't blindly hang on to this technology and instead actually analyze it, compare it, benchmark it, and perhaps even change it if you need to change it. And I'm saying that not lightly. And at the beginning, we started with David working on CO2 to CO, so conversion of carbon dioxide to carbon monoxide, which is a precursor for jet fuel. And so, we really pushed the performance of the technology to top level. We really delivered on the different milestones we have set for ourselves. And at the end of the day, we did the math, we did the techno-economics, and even then, with the best performance possible, we realized, perhaps it wasn't so better than other options that people would actually take the scale-up risk and pay for that scale-up risk. And so at that point in time, which was very early on, we were like, okay, let's go back to the drawing board. And we looked at the different products we could make, and we decided to go to ethylene, which is a much higher added value product, harder to make. But we were like, if there's a play, it's there. It's where it's hard, where no other technology can deliver on that. And so I think that's really, really important. And not only you have to coldly look at your own technology block, but you also have to coldly look at the full process and make sure you look at the full process. When you think about our technology, electrolysis, so you're converting, you're making a product, but it's mixed with unreacted carbon emission. And so, there's always a question of, you want to separate this unreacted reactant from the product. And so there's a balance, for example, to strike between the yield of your reaction and the separation cost at the end. And so you want to really make sure you're analyzing your full process and not just focusing on optimizing one thing in the middle, so that at the end you're really optimizing for industrially relevant metrics. And so I would say, if you're a scientist, perhaps bringing a process engineer early on, so that someone is really telling you about the balance of plant, which is all the auxiliary systems that are around a central technology. So now you've made all these things, you've bet on the right technology, it's working, but you've made the analysis of the process and you realize it's still a bit expensive. And so one of the traps you can fall in right now is to think that people will actually pay more for a sustainable alternative. And they will probably do if it's for a customer product that is very high-end, but most of these products, they have tiny markets, and so you're not going to have a big carbon impact by addressing a tiny market. And so the mistake is when you're oh, I'm going to make ethylene or e-fuel, and it's going to cost 4 times the price of fossil fuel, and it's going to be fine because people are going to pay forever. The fact is, perhaps the government is going to subsidize for a while, but at some point, the most energy efficient and cost efficient technology will have to win, and you better be on the side of the most efficient technology or have started doing something else at that point. And I think this we can kind of summarize by this sort of diagram where, you have on one side the goodwill, and there is goodwill in the world, that's great. And climate philanthropies are in this category, and it's really important the work they are doing. But I think it's really important, but that's my opinion, to see business as a separate category and not try and mix these two categories and see really climate tech businesses in the business categories where you really have to have economic performance in addition to your sustainability performance.